Let's look at row echelon form and reduced row echelon form. A matrix in row echelon form has the following properties. Any row consisting entirely of zeros occur at the bottom of the matrix. For each row that does not consist entirely of zeros, the first non-zero entry is 1, and it's called a leading zero. So this is why last chapter you would want to get, your system, you would always have a leading of 1, and then you could have anything else here, right? This has to be Y, and then this is Z. Okay, so that's a leading 1. For two successive non-zero rows, the leading one is in the higher row is farther to the left than the leading one in the lower row. So just formatting, this should be the far left, the X, and then the Y, and then the Z. Then a matrix in row echelon form is in reduced row echelon form when every column that has a leading zero has zeros in every position above and below its leading one. So an example of this is, let's look at D. So every leading one here, there are zeros that are below that column, and then in this case, above. So in this one, letter D, this is in reduced row echelon form. So important to notice the difference because I will be asking for this form, reduced row echelon form. So let's take a look at the other examples. Determine whether each matrix is in row echelon form. If it is in row echelon form, then determine whether it is in reduced row echelon form. So for the first example, we notice we have leading ones, and then this one is farther to the left than the next and the next, so that is good. And then we have zeros here. Now above this one here, there is not a zero, so therefore I know this is just row echelon form. Okay, the second example. Okay, notice all these zeros here, that's not in the last row, and that's what it said. Any rows consisting entirely of zeros occur at the bottom of the matrix, so this is not correct. So this is a no. The next one, we have 1 and then 1, 1 and 1. Then we have zeros here, and then above it, no zeros above the ones. So this is just row echelon form. D, we already know that's in reduced row echelon form. Letter E, notice that there's a 2 here, so that is not a leading one, so this is not in row echelon form. And letter F, what about this one? So 0, 0, 0, 0, 0, 0, that's good. The last row is all zeros. These are ones here, and then above it, there is a 0. So in this case, this one is also in reduced row echelon form. So try this example here. Determine whether the matrix is in row echelon form, and then determine whether it is in reduced row echelon form. Now, it might look a little tricky. Here are the ones. Here, 1 and 1. And then the last row was all zeros, which is great. Then notice above and below each of those ones, they are all zeros. So this is actually in reduced row echelon form. So now let's do example 6. Now instead of back substitution, I want us to go ahead and go all the way to reduced row echelon form. So we are going to keep on reducing until we get there, just to kind of see an example from beginning to end. So we're only using matrices now, so no more of the system. And so let's write our augmented matrix. Make sure you're putting zeros in place of things that are missing terms. You have your brackets and so forth. Okay, so first off, what we want to do is I want to switch the rows 1 and 2 because I see this is 1 already. So I'm going to switch the rows. So this is 1, 2, negative 1, 0, 2, and this is 0, 1, 1, negative 2, negative 3. So I did this by just switching. This is now row 2, and this was row 1. So now what I want to try to do is take care of the third row here. So I'm going to go ahead and multiply the top row by -2, and then I'm going to add it to this row here. So I'm going to go ahead and write that, -2 row 1 plus row 3. So this is -2, -4, +2, 0, and -4, and then I'm adding that with this, the third row. So I have 1, 2, -1, 0. So rewriting the first row. And then my third row becomes 0, 0, 3, -3, and -6. And then I have 1, -4, -7, -1, and -19. So now I want to get rid of this first one here. So all I'm going to do is take row 1 minus row 4. I don't think I need to rewrite that. So I'm just going to write on my rows over again. And then, so row 1 minus row 2, so let me just change these signs to kind of help me out. We get 0, and this is a 6, this is 6, this is a 1, and this is a 21. Next, what I want to do is I'm going to go ahead and change this third row. I'm going to multiply that by a third, or dividing by 3, just to get that all ones as well. So let's do that. All right, so I need this number here to go away. So I'm going to multiply -6 to row 2. So 0, -6, -6, 12, and 18. And then I am going to add that to the fourth row. So -6 row 2 plus row 4. So that's going to be 0, 0, 0. This is 13 and 39. So that's looking a little nicer. I'm going to go ahead and write that all the way at the top. Let me write it up here. And then so I'm going to multiply that one by 1 over 13 to kind of get rid of that. Okay, so now I want to get it to reduce row echelon. So what we're going to do is we need to continue doing this until we get zeros above and below all of our ones. So I'm going to change, I need these all to be 0. So that is my goal. Let's work backwards. So what I want to do is get rid of this -1. In order to do that, actually all I have to do in this case is add row 4 plus row 3. So I'm going to rewrite here, and my row 2 is the same for now. So notice when I do that, when I add row 4 plus row 3, I get 0, 0, 1, 0, and then 3 minus 2 is 1. So next we want to get rid of this 1 here. And so what I'm going to do is I'm going to take row 2 minus row 3. So this is 0, this is -1, 0, and -1. So this will become 1, 0, -2, and -4, and then write the rest. Then in order to get rid of that negative 2, I'm going to multiply row 4 by 2, and then I'm going to add it to row 2. So this is 2 and this is 6. I'm working with these here. So 1, 2, negative 1, 0, 2. So this is 0, 1, 0, 0, and this is a positive 2. Then 0, 0, 1, 0, 1, 0, 0, 0, 1, 3. So then we repeat this process again with the top line. So then I'm going to multiply this by negative 2 row 2 plus row 1. So negative 2, and this is negative 4. 1, 0, negative 1, 0, and negative 2. And then last, I'm going to add row 1 plus row 3. Okay. And so what this means is that now this is X, Y, Z, and W. And so what we get is X equals negative 1, Y equals 2, Z equals 1, and W equals 3. And then of course you write it as a coordinate, negative 1, 2, 1, and 3. And this is all done. And then, of course, again, this is what I am going to be looking for, is this reduced row echelon, which is unique, right? Because that is a solution to the system. So there may be different ways of how you possibly would have solved this equation, but at the very end, this would be the same.